Good afternoon, Susan and Christian.
Hello, Susan. Hello, Christian.
Excellent. Welcome to CYSAT. I got some handshaking signs of the tech team saying it's not ready yet, so we can have a quick chat. Maybe you can introduce yourself as a speaker before you actually deep dive into the presentation.
Sure. So first of all, good afternoon, everyone, and thank you very much for having us. My name is Susan. I'm an enterprise architect with CGI, and as an enterprise architect, my main focus are cool cloud solutions. So it's my job to bring innovative, modern, state-of-the-art solutions to our customers.
And my name is Christian Rückriegel. As a senior consultant for CGI, I work as a subject matter expert for cybersecurity. And well, my job sometimes, unfortunately, is to tell Susan what she cannot do.
What a pity. So let's dive into it. First of all, I would
just to. Oh no, I got the green light. It's all good. You guys can go ahead. Sorry about the interruption.
That's fine. First of all, we quickly would like to check on CGI because I bet there are a couple of guys inside of the audience who don't know CGI. A colleague of mine usually introduced CGI as one of the best hidden secrets in the European market, which is quite strange because CGI is as old as I am, not as young, 44 years. We are one of the largest solution independent companies, so we are not selling any specific software products as such. We are not selling any hardware. We are selling end-to-end solutions, and with that one, we are pretty independent and can choose what is the best for our clients. When I talk about we, who is we? So beside Christian and myself, there are 67,000 more of us. And yeah, we are serving more than 5,000 clients across the globe. But I do not want to become too boring with telling you what all great things CGI is doing for our customers. I would like to get quickly into some facts, which might give you a good overview about what CGI is doing and what we are doing. So as we are talking here in this conference, of course, the focus is what we are doing with space. And something what is quite impressive is that beside of the 200 space missions we have been supporting, and I'm sure that those things like Galileo, Rosetta, and those kind of programs, everyone in the audience is aware. Beside that one, we are holding a quite nice and quite impressive world record. So we are the holders of the world record of the largest distance for a software upgrade. And when you are normally talking to your colleagues which are down on Earth and doing things like just letting planes flying around or things like this, a software upgrade is something very different if you have to pass 1 billion kilometers. Beside of that, security is very important to us. It's a key factor inside of our company. And just a nice figure there is the 43 million cyber attacks, just one of our larger SOCs in the military spaces preventing every day. So that gives us quite some knowledge, which the 76,000 of us are bringing to the table. But now, ready for launch, let's go into the topic. So what we want to talk today about is a typical conflict. So let's say I'm one part of that picture. What is my desire is bringing up-to-date and leading-edge technologies. And cloud is something what you can't deny at this moment anymore. It's long ago that people were thinking and saying, well, that's just another type of modern thing. It's the benefit of high scalability and the flexibility and the speed of innovation cloud can bring to you is what our customers are asking and what the business of our customers are asking for.
On the other hand, of course, space is a very specific environment. We have a preference for proven and validated technology. We want technology that has this track record of reliability and safety. When you look at a cloud stack, there are a lot of moving parts, and this inherent complexity, unfortunately, also is a risk. For example, look at transparency. Looking at a cloud stack and knowing what's going on at this instant in time with a certain level of confidence is not always easy. Solutions are surfacing, but still, there's still this track record to build. And of course, the innovation and the agility, those are nice to have, but they're often at odds with strong requirements for AIV, so assembly, integration, verification, and the need to accredit our systems. Apart from that, we cannot usually outsource mission-critical parts into a cloud.
So I think you all have heard already a lot of keywords just in this couple of first minutes, but let's bring that down to what it really is about. I think most of you know what a cloud is, so let's dig into it. What does it mean if we are building a cloud platform and designing a platform for space solutions? So we have built around of those kind of topics our 6 principles. But before we are going into the 6 principles, let's look into it, where we came, where is the knowledge coming from that allows us to build those 6 principles. It's coming from space know-how. Of course, we have as well today a couple of colleagues inside of the audience, which are working since a very long time already with space. We have the cloud and platform know-how, where we have a couple of thousand colleagues across the globe working on those kind of technologies. And something what I think makes us special are the client insights, which I would like to touch base in this picture. So this is something which is quite interesting. So once a year, we are sitting together with our clients in deep dive sessions and really putting together the thoughts around what is specific for your industry, what is your worry, what is it what drives your business, and we are putting this together in a let me call it kind of Gartnerish fashion, and bringing out a kind of a client insight report which allows us to see the whole picture of where the different markets and where the different clients are coming from. And surprise, surprise, what are we talking today about? We are talking about cloud and we are talking about cybersecurity. And what you will be able to see if you're checking out our client reports, that are the 2 most important topics as well our clients in the space sector are talking about. So what is it what we are making out of this kind of knowledge? We are making out of this the 6 design principles for space, cloud, and platform solutions. Those 6 principles, in high level explained, this is first of all technology-based space know-how. You have to understand your customer. We have to understand what is space, what is driving space, what are the requirements, dependencies from space. We have the strong need and requirement of autonomy and independence, especially in regulated environments, which drives the requirement of building the environment and your modularity base. Of course, this all is only possible with a high grade of automation, which again has to be built modular, which again has to be built in an autonomous and independent way. And what is typical for technologies in these days, you have to manage your moving target. So, and last but not least, the most important topic for the day is security. And security is much more than just a SOC solution or something like this. And when Christian moves on the next slide, you will see that all of the 6 principles are somehow as well tying together and are glued together as well in the security aspects. Christian, over to you.
Okay, before I now talk about what we can do for security, or what we are seeing in as needs in the projects and where security is moving in space. I mean, we already heard a lot about, for example, post-quantum cryptography, but I don't want to go that far, actually. Let's first look at the brownfield, look at our existing projects, look at the things we are seeing in day-to-day business with various clients. So modularity and vendor independence as the first 2 points. They are, in my opinion, very much tied together. So mission control systems or space software and space products often are still very monolithic. So they are modular at the level of exchanging an entire server or entire virtual machine. So some solutions then are frequently actually tied to the underlying platform. So we are not yet at the point where we have adopted microservices on a broad scale. And we're not yet using the full capability of the cloud as a means of abstraction. When it comes then to this moving target, Big Bang evolutions are unfortunately still the norm instead of a continuous evolution with new features. And addressing this on a technical level is comparatively easy. So we can add DevOps or DevSecOps into the lifecycle of a project comparatively easy. But to be truly agile, we also need to look into how we can evolve our client relationships. So adopt agile at a far broader scale than just in your development environment. Even if you're doing the best DevSecOps that you can in your development, there's also the operations, there's the deployment, there's the testing. There are many more aspects to consider than just your local development team. This ties in nicely also with the automation aspect, because we see in space a lot of reliance on manual processes. For example, report generation, maintenance, and validation. Frequently, they rely on human intervention. And we see a need here for space-aware process automation. So the processes in space, be it whatever standard your mission is following, these should be automated as far as possible. Reports should not be typed by human beings. They need to come out of the machine, and you need to be able at any point in time to inspect what the current status is. So similarly, we have technology and space, and a lot of space solutions are, of course, homegrown or proprietary. So these have a tendency to become outpaced by the market, and as they are tightly integrated with the systems they maintain, it's sometimes not feasible to adapt, for example, your security monitoring solution, which may be provided by a vendor, may be outsourced. You cannot always adapt these to match the needs of space. However, space can become more interoperable. If you have your homegrown mission control system anyways, you can also modify this mission control system in a way that you can talk to your SIEM solution and become part of the security monitoring. And that actually brings me to security. Unfortunately, in many projects, security requirements come in quite late. We've heard it today. Nowadays, most projects have security requirements at different levels of granularity or detail, which is a good thing. So for new missions, I would say we are moving in the right direction. On existing missions, however, this is much more difficult because you have long-running missions. The software is already in use for quite a while, and as said before, evolutions take time and space. So our suggestion, be ready. Deploy your toolset today, even if you don't have a security requirement yet, or if the security requirements are high level, start adopting a security mindset right from the get-go. And coming back to security again, this is what I call the space edition for security baked in, not bolt on. So security from the ground up, looking at the entire life cycle of the project or your mission. So we begin obviously at the beginning with the developers. So adapting, hardening, and best practices from other sectors is something we in CGI have done successfully. And for example, when you look at agile approaches, there is a kind of a conflict because many space projects draw on the ECSS standards, which are good standards, but they use a different development model. So there's a challenge in tailoring agile approaches in a way that we can still achieve ECSS compliance. Looking forward to secure operations, for example, there's a need to balance security versus missions, or versus the mission needs rather, because while in a traditional let's say ground-based environment, I can usually shut everything down to combat a security threat, for example, a ransomware infection. I do not have that luxury in space necessarily because there are valuable assets at stake. So we need a good feedback loop, a tight feedback loop, a tool-assisted feedback loop actually, to communicate between mission and operations, to have proper authorization processes in place when we need to react to a security incident. And traditional manual approaches are simply too slow. So going forward and looking at the supply chains, I mean, everybody is probably aware of the SolarWinds supply chain attack, which was a prime example of such an attack, which unfortunately has a huge impact across the entire globe, actually. And in space, we always have to deal with obsolescences of whatever kind. It may be that your software or hardware is no longer supported, but it also may be that the vendor is no longer trustworthy, as it happened in the SolarWinds case. So we should strive to avoid vendor lock-in wherever possible. And if we have a vendor at the heart of our systems for your crown jewels, so to speak, have an exit strategy. Look at ways how you can exit a certain vendor. And that's not necessarily because you don't trust the vendor, but because you're ready in case something happens. And of course, you want holistic monitoring. And by that, I mean your solutions must include the entire chain. We have seen how different spaces from traditional environments, we have to deal with ground stations, we have to deal with spacecraft. And the usual cybersecurity tool sets are very good, but they're usually not ready to deal with space. So invest the necessary time to tailor these solutions to meet your mission's needs. All right. I've also brought you something else today, and that is a bit of a study that I've put together, looking at our design principles and looking how I would apply them to a new ground segment if I had to develop one today. And mind you, this is of course not complete. There are many aspects to developing a ground segment that I cannot cover here. But this is a way I would now go look at this challenge. So of course, we start with security. That's why we're all here. And this includes the streamlined authorization process. I believe that thinking about this has to start at the get-go. So we are looking at the entire life cycle of the project. Also look at your operations concept. Look where security needs to interface with the mission operations. Then there's, of course, legacy systems. Even in new missions, you might have to reuse software or components from other missions or that have, let's say, a heritage to them. And some of those, like I said before, are actually monolithic. You will not be able to change that in the short run, but you cannot also change the schedule of a space mission usually. So the objective here must be to mitigate. Bring them into a secure environment, mitigate by applying patches, try to migrate them towards more secure baselines, so more up-to-date operating systems, or even containerization where possible. But the bottom line here is legacy systems always need special attention from security. And going on, we're looking at the supply chain again. So one first measure to be able to have that exit strategy I talked about is, of course, to modularize. And this gives rise to the ability to replace your vendors and to build your end-to-end chain in a modular fashion by using standardized interfaces. When you look into this space, you might also look into open source and using open source as a means to ensure this independence. And this, to me, is a very important trade-off because, of course, we do not want to preclude working with our proprietary partners. However, leveraging open source can be part of this exit strategy I mentioned before. So when you have a proprietary solution like for your storage, and you have an open source solution that you can just drop in as a replacement, even temporary, you have options in case a vendor or a product goes into obsolescence. Now, of course, open source has a total cost of ownership as well. So this needs to be carefully traded off between the costs and the risks of going with an open source solution. And of course, there's high availability. This is something security is not always talking about as much as it should. However, even during a security incident, even in the most severe of cases, usually you want to keep your mission operations alive. And you still need to do your security enforcement. So even if half your infrastructure is down, you need to have security enforcement. It's not an option to, because you're treating one incident, let the other one happen. And finally, moving onward to the difficult decision, where to put what. So you have the public cloud with all its abilities. And of course, you want to leverage that, especially when you have to do large scale computing. It is much more or much nicer to not have to deal with thousands of servers yourself. At the same time, a private cloud can also offer some nice benefits in terms of having this cloud ability, this abstraction layer between your hardware and your software, and still retain full control over it. The solution to that, in my opinion, is to have a careful risk assessment. Identify your assets, classify them, know what you can share. For example, scientific data that is for publication in any case can be processed at scale in a public cloud. At the same time, your mission control system, your key management, the most important parts of your mission, I would strongly advise against outsourcing those. And that is it from my side.
Yeah, thank you very much. So I hope we could give you a slight overview about our 6 principles. Let's say Christian and I would like to thank you already for your attention. And I think I would like to say we are looking forward to meet you again next year before we are taking your difficult questions, of course, and maybe talk about another bubble of the 6 principles.
Great. Thank you, Susan. Thank you, Christian. We do have a couple of questions. I'll start again, and then I'll leave the floor to Sasha. Alex, I liked how you emphasized really the dilemma of space players these days that need to be that are facing the trade-off between deploying monolithic solutions which have great heritage and are perceived as very reliable versus cloud-native solutions that are a lot more agile, but that are raising some questions about security. And I like how you emphasize this potential hybrid model that could be a combination of the two. Ideally taking the best of the two worlds. Do you have any examples of clients or space operators or ground segment providers that are actually implementing a hybrid model between like legacy solutions and cloud native solutions?
Unfortunately, none we are allowed to speak about right now. We are doing it well, let me put it different. In the space segment, we are at the moment not allowed to talk about this. There are a couple of things going on. I would like to grab an example from another client where actually we are allowed. They are just going a little bit deeper. So we are talking about the airline. There, the classification between what goes where and what is the requirement individually goes very well in line with what Christian was telling as well. It's not as strict there because a plane is not a satellite, but the ground problems are quite the same. You always have to balance based on the data importance and based on the business data. You always have to balance what we sometimes call a little bit the battle between the leading edge and the bleeding edge. You know, the two letters difference, which are existing as well on technology side where you have to see. So everything where you're saying you're exposing your data anyhow to the public. Don't waste your time and don't waste your money on the data center. You have to be agile, you have to be fast, go to the public cloud because the data is anyhow public. But when we are talking about things, what Christian was describing as the crown jewels, especially in space, that's not the right time yet to put them on the public cloud. And we really would like to put the emphasis on yet, because the general picture of cloud being unsecure is not the right picture. You can make cloud very much secure, but you always have to balance between how much can you hand out, can you give into somebody else's hand, and how much you really have to keep under own control. And I liked when we prepared everything, we were talking a lot about key management. You do not want to have your key having in somebody else's hand than your own.
Okay, so maybe I will follow up on your answer. So we see now more and more hardware security module technology in the cloud. So what would be your recommendation with respect to using this technology? So we are not there yet.
The recommendation would be always to keep things like the ESIA forest inside of a classic data center as of now. This will change as well over the time, and use for everything where you have already public available data or public exposable data, use as much as possible already the cloud technologies. Is that answering your question?
Yep.
So you're advocating the hybrid model in the sense
Yes.
that to split what is extremely sensitive, the crown jewels as you call it, from the rest which is non-sensitive that you can deploy on the public cloud, if I have understood you clearly. Is that correct, Susan?
Yeah, that is correct. If I may add to that,
Sure.
it also does not preclude us to use modern cloud security features. For example, like HSMs, you still would like to preserve your public data, and in the future, these may allow us to put maybe even data with medium security requirements as opposed to public data only. So we may be able to put more classes of data confidently into the cloud, but we're not there yet. It's evolving, and we're monitoring this very closely.
Very interesting. One more question on my side. You also made a similar comment to Alexandre this morning. He said this morning, you have to know your system. It's almost a philosophical remark, and you said something very similar. Can you maybe take examples or tell us a bit more about the journey with your own customers trying to go through this methodology and how they take it on their side if they're not familiar with cloud computing and these solutions?
Everything starts with cultural change. So when you want to use modern technology, it doesn't make any sense if you want to go into the cloud and only see it as just another computer. It's cloud usage, whether it's private cloud or public cloud. If for you it's just another data center, then you most probably have failed already in the first step. So from our experience, everything starts with a cultural change, where the digitalization as well in space goes across everything. It's a change of DNA. It's a change of failure culture, which is, of course, in space a very sensitive topic. You can't just, as Christian said so nicely, you just can't throw it away. If the satellite is in the orbit, the satellite is in the orbit. You just can't say, okay, better luck next time, right? So, but really see that from a complete thing. Using modern technology goes hand in hand with change of DNA, is going hand in hand with change of new structures of how your service management is, for example, working. If you're building a beautiful build chain, and we are seeing this as well outside of the space area with a lot of customers, if you build your automation, but your automation has to stop at every step, and somebody has to give manual approval, then why take a build chain? It's not helping, right?
Yeah. And one more comment, and I'll take a couple of more minutes. I was about to talk about the modern DevOps practices using containerized software applications, which make it actually easy to have this split between what is extremely sensitive and what is not.
Yep.
I don't know if you have clients using Docker or Kubernetes. Do you recommend these tools to implement the hybrid cloud options?
Absolutely. Especially with Docker or with Kubernetes, there are now standardized containers which allow you to actually move your workloads across different cloud providers, adding to this vendor independence part. And also you can move these into your own data center. So we've just said that the cloud is not, in our opinion, ready for, let's say, payloads with a medium amount of security needed. So you only put the public data onto the cloud. But when that changes and you have a standardized, or as far as possible standardized container-based architecture, then the migration will be all the simpler. You can then just take your containers, reconfigure them, put them onto your chosen cloud provider. And if that cloud provider changes their licensing, their pricing, or their APIs, you can move to the next one at least.
Yep.
And maybe if I can add to this goes as well into the aspect of modularity and of microarchitecture. Mm-hmm. You're making yourself in a financial way, in a vendor independence way, in a security way. You're making yourself so much independent from a lot of trouble, from a lot of stress, and that helps you at the end to gain higher flexibility, better cost base, and of course you make your security life more easier. Doesn't mean that if it's in a container it's per se secure. But you're eliminating, or you can standardize a lot of other things which are from a hierarchical level below.
Yep, fully agree. Do you have any examples again on monolithic solutions? I'm thinking about the famous EGSCC, for example, or other mission control or ground segment applications that were using legacy solutions and that have been transferred to DevOps, containerized, or using. Do you have examples from that? Or is it too
you
early?
Really want to bring? Well, it's part too early and it's part against NDA.
Okay. Fair enough. Okay. Any question on your side, Alex?
No, I think we're good. So let's wrap up.
Yeah, excellent. Thank you so much.
Thank you very much,
Susan and Christian. He was.
Thanks for having us.
Thanks for having us.
To have you. Thank you for being part of CYSAT 2021.